Good day everyone, JUL-ARSER MAGD here, and today we are going to discuss about the star clusters. A star cluster is a collection of stars with a common origin that are gravitationally bonded over an extended period of time. Astronomers benefit from them because they allow them to analyze and model star evolution and ages. Open clusters, also known as galactic clusters and globular clusters, are the two types of clusters. Let's go to the third slide. The individual component stars in open clusters are easily resolved through a telescope, hence the name. The Hyades and Pleiades, for example, are also close together that the individual stars can be seen with the naked eye. Due to their location on the dusty spiral arms on the plane of spiral galaxies, they are sometimes referred to as galactic clusters. And open clusters stars share a shared origin. They all arose from the same massive molecular cloud. Clusters usually have a few hundred stars, but this number can range from a few dozen to a few thousand. The jewel box cluster is one of the nicest open cluster to observe with a small telescope in the southern sky. In cruise, it is close to the star Crosis. Gravity holds stars in an open cluster together only loosely. Due to gravitational disturbance with other objects in the galaxy, the clusters gradually disperses as it rotates around the galaxy, while our sun is thought to have formed in an open cluster. There is no evidence of surrounding stars clumping. As a result, open clusters are typically young objects. Some, such as the Pleiades, still have nebulosity, indicating that they were formed recently. Population 1 star are open cluster stars that they are young and high metallicity. Clusters can range in size from few to 20 or so parsecs across. The Pleiades, a young nearby cluster. The faint blue nebulosity is the reflection nebula and suggests that the cluster formed only recently as it has been as it has yet been totally blown away by the UV radiation from the hot blue stars. The Pleiades is known as the Seven Sisters in several cultures as Sobaru in Japan. Now let's go to the fourth slide. Globular clusters are spherical gravitationally coupled systems that contain thousands to millions of stars. They are typically found in the halo encircling the galactic plane and are the galaxy's oldest star. These stars in population 2 are highly developed, although their metallicities are low. Any star higher than G or F class will have evolved of the main sequence by the time it reaches a cluster. Because globular clusters contain very little unbound dust gas, no new stars are formed there. When compared to regions like those around the Sun, stellar concentrations within the inner parts of globular clusters are extremely high. Ground-based AAT and HHT image of the globular cluster 47 Tuk. 47 Tuk is approximately 4,600 parsecs away. Many stars are red giant Many stars are red giants and white dwarfs because they are around 10 billion years old. Stars in globular clusters, like those in open clusters, are most likely related. Unlike open clusters, globular clusters are gravitationally cohesive for the majority of their lifespan. The stars that make up the clusters are not dispersed. There are around 200 globular clusters in our Milky Way. 47 Tuk, M4, and Omega Centauri are notable examples, albeit there is considerable controversy about whether or not this is a captured dwarf spheroidal galaxy. Star clusters are particularly valuable because they allow astronomers to test stellar evolution models and determine the ages of stars. Let's start with open clusters to see why this is the case. The stars in an open clusters all come from the same nebula. As a result, they have the same starting metallicity. Therefore, any effects of stellar evolution is virtually the same for all the cluster's member. Another crucial factor to remember is that all the stars in a cluster are effectively the same distance from one observer on Earth. Even though a cluster is only a few parsecs across, its size is inconsequential when contrasted to the cluster's far greater distance from Earth. If we take photometric readings of the cluster stars, we can deduce the relative absolute luminosities of the cluster members based on their apparent magnitudes. The brightest stars in a clusters are inherently more luminous than the fainter components. The fact is used by astronomers to create a color magnitude diagram of a cluster. So this is a simple HR diagram in which the apparent magnitude, generally V or MV, is plotted on the vertical axis against the color index, BV on the horizontal. They can then calibrate the diagram using stereoscopic parallax to obtain values absolute magnitude, M or MV. We get an intriguing outcome when we perform these numerous open clusters. Some open clusters are shown in the image here. On the left, we have the H plus Persei, a double open cluster separated by only 30 parsecs despite 2,200 parsecs apart. And the other one is the M67. It is located here in the right. Persei and the double open cluster H. This pair is notable for the enormous number of young brilliant O and B stars in both, as well as their near approximately while remaining distinct. M67, the cluster on the right, is substantially older. The multiple white dwarfs within it have been dated to be 4 billion years old. There are no hot dazzling stars to be found. Okay, to sum everything up, star clusters provide one of the best tests of our calculations of what happens as the stars age. The stars in a given cluster were formed about the same time and have the same composition, so they differ mainly in mass and thus in their life stage. There are three types of star clusters: the globular, open, and associations. Globular clusters have diameter of 50 to 450 light years, contain hundreds of thousands of stars, and are distributed in a halo around the galaxy. Open clusters typically contain hundreds of stars, are located in the plane of the galaxy, and have diameters less than 30 light years. Associations are found in a region of gas and thus contain extremely young stars. And that's all for our discussion. Thank you for listening.